Okay, this is section 8.2 in MathLinks 9 on solving two-step algebraic equations with both fractional constants, coefficients, and fractional values on the other side. So the 4 questions ask us in the first one, solve with opposite operation. And remember, if I gave you the question x over 2 plus 3 equals 5, I said solve that question. The first, Alex, stop texting me during my video. Uh, the first thing you would do is get rid of your constant, because that's what we learned to do in grade 7 and grade 8, is get rid of your constant first. So I would subtract 3 because the constant's the first thing, and then I would multiply both sides by 2. So given the fact that this is still just a constant that is a fractional value instead of a whole number value, the first thing I'm going to do is subtract 3/5 from both sides. I'm going to be left with half of x equal to whatever 1.5 take away 3/5 is. So we know from grade 7 that 1.5 is equal to 3 halves. Take away 3/5. We know that when we subtract fractions, we need common denominators. And 15/10 take away 6/10 is 9/10. So we now have a one-step equation because we've gotten rid of our constant. Half of x is equal to 9/10. My next step is, of course, to multiply both sides by 2. And we learned in grade 8 that when you multiply a fraction by a whole number, the easiest thing to do is consider that whole number to be over 1. If you multiplied your numerators and multiplied your denominators, you get 18/10, which is equal to 1 and 8/10, which is equal to 1 and 4/5 in lowest terms. Now, if you cross-reduced, you would have ended up with 9/5, which is 1 and 4/5. Now, one astute student just said, couldn't you just have changed everything to decimals? And if you did that in blue, this is the equation you would have created with decimals. Half of x plus 3/5, which is 6/10, equals 1.5. And if you did do it that way, yeah, you could subtract 6/10 from both sides and then divide both sides by 0.5, and you'd have the same answer. Which, of course, is 1.8, because 1 and 4/5, if I was to work it out, my answer should be 1.8. In the second question, we have almost the same. It says solve with multiplying by common multiples. So this idea of equality, a balance of equality in algebra, is something that we preached to you in grade 7, and we preached to you in grade 8. And basically we said if I subtract a half from both sides, it keeps it equal, right? It keeps it balanced. But what we never told you in grade 8 was that if you multiply both sides by a common number, you will still maintain equality. So what I'm going to say here is I'm going to multiply both sides by 20. And we know from our experience, whatever I do to one side, if I do the same thing, it's going to maintain balance because the weight of both sides currently is balanced or equal. So here's what happens. If I multiply this side by 20, and the reason why I chose 20 as opposed to a random number is because the denominators, 5, 2, and 4, the first multiple they share, if I was to look at their multiples of 5, 2, and 4, the first multiple they share is 20, if I was to actually continue those out. So x over 5 times 20, or a fifth of x times 20, if you work it out, will be 20x over 5, or 4x. 1/2 times 20 will be plus 10. And 3/4 times 20, if I work it out, would be 60 over 4, which is 15. So by making this equation 20 times bigger on both sides, I create a new equation, 4x plus 10 equals 15, that does not have fractions in it. Okay? And because it doesn't have fractions in it, oh, hello, it's going to let me solve it in a much easier way. So I'm going to bring this up, give myself a little bit of room. 4x plus 10 equals 20. I'm going to subtract 10 from both sides. I get 4x equals 5, and then I'm going to divide both sides by 4 to get equals 1 and 1/4, or 1.25. That's your answer. That one seems a little bit more complicated, but it's not that bad. In your next one, the variation in the third one compared to the first one is your constant. Sorry. is your constant is your first term and your variable is your second. But I'm still going to subtract 3/4 from both sides to get rid of the constant. I have 2x equals, so 3/8 take away 6/8 will be negative 3/8, right? Negative 3/8. And once I have that, I'm going to divide both sides by 2. And whatever negative 3/8 divided by 2, so what do we do when we divide by whole numbers? What do we do? We change it to the multiplication by the reciprocal. And what's the reciprocal of 2? A half. So when we do so, we're going to multiply our numerators. What's negative 3 times 1? It's negative 3. What's 8 times 2? It's 16. So our answer is x equals negative 3/16. And finally, the last question, solved by multiplying by a common multiple. Here, my denominator is, I'll take my highlighter. My denominator is 3. My denominator is 3. And my denominator is, no, it's not 6. 1. It's not written, but we know it's 1. So what's the first multiple that 3, and 1 share is 3. So I'm going to multiply this side by 3. And I'm going to multiply this side by 3. So negative 4 2/3 multiplied by 3 is the same thing as negative 12, negative 14 thirds multiplied by 3. Of course, if I cross reduce here, Bob's your uncle, because what's that going to give me? Just negative 14, right? If I multiplied it by 3 and then divided by 3, I'd still end up with, when I simplified that, as negative 14. Here, x divided by negative 3, I have to use distributive property because both of these have to be multiplied by 3. So when I multiply this by 3, I get a negative x. Sorry, do I? No, I don't. Yes, I do. I get a negative x. And here, 3 times negative 6 is negative 18. So by multiplying both sides by 3, I create this monstrous equation, in which case I will add 18 to both sides to get 4 equals negative x. What's the coefficient of negative x? So I have to do what to both sides? Divide both sides by negative 1, and x equals negative 4.